So, I am going to teach you about z-scores today. So, if I came to you and said, hey, you got 80 on the test, and then that was the only thing you knew, you got 80 points on the test, and you didn't know anything else about the test, how many points it was worth, that score is not going to give you much information, right? If I just tell you that your value is 80, you're going to want to know lots of other things, like how much was the test worth? How did the other kids in the class do? What was my percentage correct? All of those questions. Most of those can be answered using what we call a z-score. So, if your score is 80, you probably want to know how you did compared to everybody else. So if I told you, so let's say you're person number 3, your score is 80, and the X bar, the average or the mean, is 95. All that really tells you is that you did worse than average. Your 80 points were worse than average. Is that score unusual? Well, we don't really know. So if I were to graph all of the class scores, we would expect a normal curve, a normal distribution, and we know that 95 is in the middle. And if I did this with every person in class, or over the years, all of these dots represent individual people. So if your score is right there, then you were about average. However, if your score is clear over here, then it was extremely unusual and you are far below average. So what we do is we measure the distance from here to the inflection point, and that is usually 1 standard deviation. And remember, standard deviation is described as the average distance from the average. It's actually a little bit bigger than the average distance from the average, but we could just call it that. And standard deviation is something that we can calculate once we have everybody's scores. So let's say that the SD of the class was 5. That means that most of the people in class scored somewhere between 90 and 100 points. In fact, about 68% of the class should score within that window. All right? If we go out another standard deviation, so this is 90, and this is 85, and this is 100, and this is 105, that should capture about 95% of all kids that took the test. Just as a side note, there are, 20 kids in this class? Is that enough to get a normal distribution? If I only give the test to 20 people, am I going to get a nice normal curve? No. I need to give this test to hundreds, probably thousands of kids. And once I do that, then I'll have a nice normal curve. All right? And if I go out one more standard deviation, 80 and 110 points, then that should capture about 99.7%. So what do we consider normal? Well, normal is a bad word. What do we consider usual? Well, anywhere within 1 standard deviation is pretty usual, right? About 2/3 of the people score within 1 standard deviation, okay? Anything outside of 1 standard deviation starts to get a little bit weird. When we're dealing with p-values, if we have a tail, and this tail is less than 5%, we consider that really unusual, and that's where we say, hey, that coin you're flipping, something's wrong with it. Or more people are dying at that hospital than they should. Okay? So we can actually calculate what is called your z-score. And your z-score transfers all of the information about this graph, the standard deviation, and the mean, and your score into a single number. And the z-score is essentially how many standard deviations are you away from the average. So some of you have already started on the worksheet. Nice work. But I am the most important thing in your life right now. So what is the z-score for 80? Well, we need to figure out how far away from the average is 80. So how far from 95 is 80? 15. And it's actually 15 points lower. So I'm going to say it's negative 15, right? Well, how big is negative 15? In terms of the standard deviation, it's 3 standard deviations below average. So this is 1 SD, negative 1 SD. This is negative 2 SDs. And this is negative 3 SDs. And if you are 3 SDs below average, oh, Jacob, you were doing so well paying attention. You really were. You you can do this. So if you're 3 standard deviations below average, that is very unusual. Not many people land over there. If you're rolling a fair dice, can you get a score that is 3 standard deviations below average? Sure, but not very often. Okay, so the formula for the z-score is simply value minus average divided by SD. And that single number will compare you to everybody else in the class. So at the beginning of this, I said your score is 80. And without any other information, that number is pretty useless, right? But if I told you your z-score was negative 3, now all of a sudden you're having a bad day, right? One number did all of that. Do you know what you scored if I tell you your score was negative 3, your z-score is negative 3? No. You don't know your score. You don't know how many points the test was worth. You don't know what the average is. You don't know what the SD is. But you know that you are probably the worst score in the class just by knowing that your z-score is negative 3. What if I told you your z-score was 0.25? How did you do? You were pretty darn average. A little above or a little below? A little bit above average. Okay? So anybody over here is going to have a positive z-score. Anybody over here is going to have a negative z-score. So positive 0.25 translated means you were 0.25 SDs to the right because it's positive. Okay? All right, what if your score was, let's say, 103? What is your z-score? Well, it's always value minus average. Why do we do value minus average? Because that makes the numbers on the right positive and the numbers on the left negative. So 103 minus the average of 95, and that gives 8. Divide that by 5, and I get 1.6. What does 1.6 mean? 1.6 standard deviations above average. Does that make sense? Okay. What if I told you your score was, your z-score was 2.6? What was your score on the test? Well, first of all, how did you do? Very well. You're in the top, like top 1%, right? Okay. Is that score unusual? Quite unusual. Yeah, right. Top 1%. Yeah. So how do we calculate what you got on the test? Well, this is in SDs. How much is each SD worth on this test? 5. So we're going to take 2.6, and we'll 2.6, and times it by 5, and I get 13. What does 13 tell me? The difference between what you got And what the average student got is 13 points. And it happens to be 13 to the right because it's positive. All right? So what do we do with 13 to find your score? Add it to 95, and that gives me 108. And you can see here, 108 is right there. How many people are over here? Very, very few. So anything above like 1.5 or 2 SDs is pretty unusual, right? Most people are within 1. The vast majority are within 2. So anything, once you start to get close to 2, that becomes unusual. Anything beyond 2 is quite unusual. Okay. I don't know why this is making noise, Garrett. Sorry. Turn it around, see if it makes less
You're
noise
good.
for you. All right, so let's do another one. Let's say, we looked at how many points are scored in all of the baseball games, baseball and softball games in Utah last year. All the high school baseball and softball games, okay? And we see that the average number of points is 5.2 per game, and the SD is 1.8. Okay? So I could draw a normal curve just to kind of understand this a little bit better, and I put 5.2 there, and the distance to that inflection point is 1.8. So if your team scores 7 runs one day, how does that compare to all of the scores from last year? It's above average. Is it a long way above average? Well, we need to calculate the z-score. So 7 minus 5.2 is 1.8. Oh, wow. What are the chances? I didn't mean to do that. And we divide that by 1.8, and I get 1. What does a z-score of 1 mean? 1 standard deviation above average. Is that unusual? No. That's a pretty normal game, right? In fact, 68% of all games should be within 1 and -1 SD. Okay? So what if your game had a z-score of -2.9? How many points were in that game? Well, the formula for value, well, we'll write that in a minute. Let's just figure it out. So -2.9 what? Standard deviations. And how big is a standard deviation? 1.8. So if I take -2.9 and I times it by 1.8, I need a calculator. -2.9 times 1.8, and I get -5.2. So that is -5.22. What does that mean? Your team scored 5.22 points less than average. Oh, I did it. I'm sorry. Fewer than average. Can you count points? Yes, you can count points. So I need to take -5.22 and add it to 5.2, and I get -0.02, which means I probably should round it to the nearest point, right? So 0. Yeah. So in that game, your team scored 0 points. Now, weird things happen with standard deviations around 0. In some cases, negative numbers simply don't exist. So in this case, decimals and fractions don't exist, right? Nobody's ever won a game by a baseball game by half a point. That's never happened. So If I plugged in a z-score of, say, -4, that's going to give me a negative number, which in this case can't really happen. Yeah, like you were giving points to the other team. I don't know. So what would the formula be for value? Well, if you want to find the value, all you have to do is take your z-score. What did we do with that? We multiplied it by the standard deviation, and then we added it back to the average. But how did we get values to the left of the average if we're adding? Do I need to worry about that when in this formula? Should I subtract the average instead of add the average? No. What do scores on the left side of the average have? Negative z-scores. So this formula works for positive z's and negative z's. A negative z-score will subtract from the average, essentially, when you add the average to the negative number. Okay, so the two formulas, z-score is value minus average divided by SD, and the value formula is z times SD plus the average. So on this worksheet, you have a whole bunch of questions you need to answer. I'll put the answers up on the board, or they'll be on Canvas, but I haven't quite finished it yet. So while you're working on this, I will finish the answer sheet. All right, go.